Picture a rocket the height of a 15-story building lying on its side in the Indian Ocean, 800 kilometers off Western Australia, and a rope running from its nose to a tug, trying to drag it home through a rising swell.
That's not a thought experiment. That's where the top half of a SpaceX Starship has spent the last 2 weeks.
And whether it ever reaches an Australian port is, right now, genuinely up in the air. Good day and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. It's Monday, the 10th of August, 2026.
There's a thread running through today's show, things taking the long way home, a Starship under tow, a Chinese booster trying to fly itself back to the pad tonight, 40-year-old Voyager 2 data still turning up surprises at Uranus, and eclipse chasers heading to the top of the world for 2 minutes of darkness 3 days from now.
And plus, the best meteor shower of the year peaking under a new moon. It's a big week. Let's get into it. So let's go back to the 24th of July. Starship's 13th full test flight lifts off from Starbase in South Texas. And this one goes well, really well. The upper stage, the part SpaceX just calls ship, flies its suborbital arc and comes down for a splashdown in the Indian Ocean off the coast of Western Australia, exactly where it was aimed.
And here's the first ever bit. Every previous ship that came down over the ocean broke up or was deliberately destroyed. This one, Ship 40, made what observers called the softest Starship water landing yet, tipped over as it hit the waves, and then just stayed in one piece.
It floated, airtight, bobbing in the swell. Onboard cameras showed all 6 Raptor engines with no visible external damage, water lapping at the lens. A SpaceX spokesperson called it on the live webcast a dream scenario.
Which it was, because SpaceX genuinely did not expect to get this vehicle back. The whole point of the flight was the data. The heat shield is the thing that kept Elon Musk up at night for years. The tiles that protect ship on the way back through the atmosphere, and on this flight, it held.
In fact, on the 4th of August, on the company's first ever quarterly earnings call, its first since going public, Musk said, and I'm paraphrasing only slightly, that he doesn't want to jinx it, but he'd consider the heat shield problem solved.
That's a big claim. For a rocket meant to be fully and rapidly reusable, the heat shield was the last great unknown. So a ship that survives re-entry, survives the water, and floats there intact is suddenly a floating laboratory.
And that changed the maths. On the 28th of July, Musk posted simply, "We're sending a ship out to recover Starship." The SpaceX vessel Go Australis had been shadowing it since splashdown. 2 Norwegian tugs, Normand Ranger and Skimmer Tide, steamed out to join. By early August, satellite imagery showed all 3 working the vehicle, with a tow line already made fast to the nose section.
For context, this thing had already drifted more than 400 kilometers. The whole convoy is over 1,300 kilometers off the Australian coast, aiming, according to imagery-based reporting, for a Western Australian port. Dampier and Port Hedland have both been floated as the likely destination.
And then, on the 7th of August, the tone shifted. Musk posted an update. Unfortunately, ship recovery is not looking good right now. The team's been fighting increasingly rough seas. But, and this is the important part, he added that they were still able to get close-up photos of critical regions of the heat shield and the engines for future upgrades.
So read that carefully. Even if the tow fails, even if Ship 40 never reaches a jetty, SpaceX has already banked most of what it wanted, the inspection imagery. Honestly, a ship soaked in salt water for 2 weeks was never going to be refurbished and flown again anyway.
All right, the prize was never the hardware, it was the look at the hardware, which is why, as of our recording, the story is beautifully unresolved. A giant rocket, still afloat, still under tow, in a race against the weather off Western Australia.
Worth remembering how big Giant is here. Stacked, Starship stands about 124 meters tall, the biggest, most powerful rocket ever built. The ship on its own is 52 meters. That's what's on the end of that rope.
And the flight did its day job too. During the mission, ship deployed 20 next-generation Starlink V3 satellites, the bigger broadband bird SpaceX wants to fly by the 100,000. Those particular 20 came straight back down by design, but it was a dress rehearsal for the future.
The booster, meanwhile, the Super Heavy, had a rougher day. Engine trouble on descent, and it came down hard in the Gulf of Mexico and exploded. So a triumphant ship, a lost booster, and a 2-week sea drama that may or may not have a tidy ending.
And the look ahead is quick. Musk says the next one, Flight 14, is targeted for late August, and it's meant to be Starship's first crack at reaching operational orbit while carrying production Starlink satellites. So the pace isn't slowing. But for our part of the world, this is the rare week the Starship story washed up on an Australian shore. Almost literally.
Almost literally. Let's bring it home from the other direction now, because someone else is trying to land a booster tonight. Because reusability isn't just a SpaceX story anymore. Tonight, a Chinese company called Landspace is going to try something only SpaceX has truly mastered: flying an orbital-class booster back down and landing it on its legs.
And Landspace is a private outfit, founded in Beijing back in 2015. Their rocket is the Zhuque-3, stainless steel, methane, and liquid oxygen engines, about 66 meters tall. In capability, it's broadly a Falcon 9 rival.
And the timing for local listeners, liftoff is targeted to 7:45 on Monday evening U.S. Eastern Time, which is 7:45 to midnight UTC. And for us in Sydney, it's about 9:45 on Tuesday morning. It goes from Jiuquan in China's northwest.
Now, here's what we need to be precise, because the headlines get this slightly wrong. This isn't China's first booster landing. It's China's 4th orbital-class recovery attempt. And one of those already worked. Back on the 10th of July, a Long March 10B was caught using a net capture system, which made China the second nation ever to land an orbital booster.
So what makes tonight different is the method. Landspace isn't going for a net. It's going for the full Falcon 9 move, a powered descent, a powered landing burn, and legs, setting itself down on a pad downrange in Gansu province. If it works, Landspace becomes the first Chinese company to pull off that kind of propulsive booster landing.
And they've been close before. The Zhuque-3's maiden flight last December actually did its main job. The second stage reached orbit. It was the first stage that let them down. The landing burn faltered a few kilometers up, and the booster came down in a fireball. By some accounts, they were within about 17 seconds of a landing.
17 seconds. That's the margin they're trying to close tonight. A clean static fire test at the end of June set it up, and airspace closure notices point to this evening.
Why does it matter to the rest of us? Because landing and reflying boosters is what dragged the cost of getting to orbit down in the first place. A second company doing it on a different continent with a methane rocket is how a one-company capability becomes an industry.
We'll be recording before the window opens, so we're calling it forward. If you're listening later in the day, check astronomydaily.io. We'll have the result.
Now, from rocket recoveries to a planet lying on its side, there's a lovely result doing the rounds this week about Uranus, and it comes with an old friend attached.
Set the scene first, because Uranus is the oddball of the solar system. It doesn't spin upright like Earth. It's tipped right over, rolling around the sun on its side. And its magnetic field is stranger still, tilted about 60 degrees from its spin axis and offset from the planet's center. Nothing about it is neat.
Which matters for something called the bow shock. That's the boundary out in front of a planet where the solar wind, the constant stream of particles off the sun, slams into the planet's magnetic field and abruptly slows down. At Earth, that boundary sits there fairly steadily. It only really moves when the sun kicks up.
But at Uranus, this new modeling shows the bow shock is anything but steady. It swells and shrinks. It breathes over the course of a single Uranian day, which is about 17 hours.
And here's the clever bit. Because Uranus is so tilted and lopsided, every few hours a different part of that wonky magnetic field is turned to face the wind. So the shape of the shield keeps changing. The team ran simulations where they held the solar wind perfectly steady, and the breathing still happened, which means it's driven by the planet's own rotation, not by the sun.
The study's in the journal AGU Advances, led by Sin Cao and colleagues. And this is where our old friend comes in, because to anchor the model, they leaned on the only direct measurements humanity has ever taken inside the Uranian system.
Voyager 2, which regular listeners will remember from last week. It's the same spacecraft whose team just pulled off that Big Bang power maneuver to keep it alive. Voyager 2 swept past Uranus back in January 1986, caught a single crossing of that bow shock, and moved on. 40 years later, that one data set is still the ground truth every Uranus model has to match.
I love that. A 40-decade-old flyby, still doing frontline science. And it's not just trivia about one weird planet. A lot of the exoplanets we're finding out there are ice giants like Uranus. So understanding how a tilted, off-kilter world handles the stellar wind gives us a template for worlds around other stars entirely.
Fair to say, too, this is a modeling result that's been quietly out for a little while and only got its moment in the spotlight this week. But it's a genuinely new way of seeing an old planet, and a reminder that the next mission to Uranus can't come soon enough.
Right. 3 days from now, on Wednesday the 12th, the moon's shadow sweeps across the Earth for the only total solar eclipse of 2026. And this one is strange in the best way.
Strange how?
Most eclipse paths race west to east across the planet. This one goes up and over the top of the world. It begins in the Arctic over remote Siberian Russia, arcs across the North Pole, and comes down over eastern Greenland, then the west coast of Iceland, then northern Spain, clipping a tiny corner of Portugal, and finishes out over the Balearic Islands, right at sunset.
And because it's so far north, totality is short and the sun sits low. Greatest eclipse is about 5:45 in the evening UTC, just off Iceland's west coast, and even there, totality lasts only 2 minutes and 18 seconds, with the sun barely 26 degrees above the horizon.
For the places in the path, it's history. Iceland hasn't seen a total eclipse since 1954, and for Reykjavik, it's the first in 593 years. Totality there lands around 5:45 in the evening, local time. Spain hasn't had one since 1905. From Oviedo and Jiuquan, it's about 8:30 in the evening, low in a sunset sky.
Audience question. What about North America?
North America gets a partial, no totality, but a real bite out of the sun. NASA has it visible right across the northern tier, from Alaska all the way to North Carolina, and over most of Canada. The deepest coverage is up in the far north, in Alaska. By the time you're down on the U.S. East Coast, it's a shallower bite, under 10% for somewhere like New York.
And the timing for the U.S.?
It's a late morning into early afternoon event, depending on how far west you are. The simplest anchor, NASA begins its live broadcast at 1:15 in the afternoon Eastern Time at nasa.gov/live. So even if you're nowhere near the path, you can watch totality from Greenland and Spain in real time.
Which is exactly what our Southern Hemisphere listeners will be doing, because from Australia, this eclipse simply isn't visible at all. Nothing from Sydney. But don't worry, your night sky this week has plenty going on, and we're getting to that right now.
We are, because the eclipse is only half of a genuine Skywatch double feature. Avery, take us home.
Here's the gift of this week. The 12th of August gives you an eclipse by day, and that same night into the 13th, the Perseids at their peak, under a brand new moon. No moonlight to wash them out. It doesn't line up like this often.
Let's do the north first, because that's where both events favor. Northern Hemisphere listeners, this is your year for the Perseids. Dark skies, no moon, the radiant climbing high. Best viewing is after midnight into the pre-dawn hours of the 12th and 13th. From a properly dark site, you could see 50 to 100 an hour. For North America, the small hours before dawn on the 13th are the sweet spot.
And the bonus for northern watchers, the sun's been active. A geomagnetic storm lit up auroras across high latitudes over the weekend. And there's a chance of more around the 11th and 12th. So if you're up north chasing meteors, keep one eye on the horizon for the lights.
Then the eclipse recap for our North American listeners. A partial on Wednesday, late morning to early afternoon your time, deepest in the far north. And NASA's stream starts 1:15 Eastern if the sky won't cooperate.
Now, south of the equator, Australia, New Zealand, the eclipse passes you by, and the Perseids barely clear your northern horizon. So rates are modest at best. But your sky is far from empty.
Not at all. Step out before dawn and there's a spread of planets strung across the sky. Look west after sunset and Venus is unmistakable, brilliance climbing higher each evening, heading for its brightest around the 22nd of September. And low in the pre-dawn south, Comet 10P Kempel-2 is still within reach of a small telescope or good binoculars from a dark site. From Sydney, give yourself that clear eastern to southern horizon before first light.
So wherever you are, north or south, there's something to look up at this week. But before anyone points anything at the sun, only during the brief moments of totality and only if you are standing inside the narrow path can you ever look at the sun without protection. Everywhere else, and that includes all of North America, all of the sun's partial phases, you must keep certified ISO 12312-2 eclipse glasses on the entire time. Never look through an unfiltered camera, binoculars, or telescope. The concentrated light causes instant, permanent eye damage. If in doubt, watch the light stream.
And that's the show for today. Everything we covered, the Starship Tue, tonight's Landspace landing attempt, the Uranus study, and full eclipse and Perseid timings for both hemispheres is written up at astronomydaily.io with sources.
While you're there, sign up for the daily newsletter, leave us a review, and send us your Perseid and eclipse photos through the contact page. We love featuring them.
We're at Astronomy Daily Pod everywhere. I'm Anna.
And I'm Avery. Whether the skies are dark for meteors or the sun goes out for 2 minutes over Iceland,
we hope yours are clear. Until tomorrow.
Clear skies.